Yeah. Is that good? We'll do an example of function notation. Let's say the function is here's our function. When f is 2, this is how we plug it in. I replaced all of the x's with the number 2. Okay? That's a quick example of how to fill in a function notation. This was from our quiz. All the stuff on our quiz is still on our test, guys. So I give you those quizzes back. Make sure you go through them, know how to fix it. We have our f at x. This was our original function. When f was 2, we replaced all the x's with the number 2. I'll do one other difficult function notation example. Okay? I'm just going to show you how to fill it in. Sometimes they'll give us an equation like this. We're going to say we're working with the exact same function. Okay? So here's an example. Here's another example. Sometimes they'll ask us f at negative 2 minus f at 3. So we look at that. That was one of the questions from our quiz. Looked exactly like that. To fill it in, actually let's move it so it looks a little nicer. I'll put it here. So we have our new function here. That's going to look like this. We take our very first function, but we're replacing all the x's with negative 2. So in brackets, we have 3 negative 2 squared plus 2 times negative 2 plus 1, end brackets. This is our f at negative 2. Our subtraction sign goes in between. Our f at 3, brackets again, we write the exact same function from above, 3, same way we started the first one, but we replace the x's with the number 3 this time. Squared, 2 times 3 plus 1. So, let's draw a little green line so we can separate what we've just done. This deals with this question here. This one deals with this question here. Okay? We still use the exact same function from above. It was just written differently. F at negative 2 subtracted by f at negative 3. So I have to rewrite that function twice. And both times we replace x with different numbers. Then I have to carry out my bed math. That's all the stuff we did on the very first quiz of the year. You have to know how to do that already, okay, guys? But I'm just showing you how to set it up. This is an example of how to set it up. It's on your quizzes. Always keep your quizzes, okay? Go through them again. Do we take them up? No. We do not have time. Anytime you get something wrong on a quiz, do your best to find out what the answer is. Come to me. We'll try to take it up the next chapter coming through.
Sure, how do you do those things? Like I'm looking at one of the quizzes with like the arrows and the numbers.
Okay, on your quiz you had something that looked like this. Here's another example. This is set notation. This will deal with our x. This oval will deal with our y. They've given us some numbers, let's say 3, 4, and 5. I think that's right out of the quiz, isn't it? And 2 and 1? Yeah, I think that's what they've done. Okay? First of all, we have to know if it's a function. That was one of the questions from the quiz. I think, is that what it looks like, Tom? Yeah. Okay. So what this means is we always look at our x. We have 1, 2, 3, at least 3 coordinates, because there's more x's than y's. I just go to the one that has more numbers. That's how many coordinates I know I'm going to have. So I know my very first coordinate is going to be 3. So my x is 3. My y is 2. That's one coordinate that I have. Another coordinate I have, x is 4. An arrow points to 1, y is 1. Another coordinate I have, x is 5, y is 2. Okay? Now, I have my 3 coordinates. One of the questions asks us to tell if it was a function. So, a good way to do this is we'll quickly... Okay, we're going to graph these 3 functions. So, we're going to assume all these points are at just moving by ones, okay? For time's sake. So, our very first point, x is 3. There's 2, 4, 6, and 8. X is 3, and y is 2. That's one of the points on the graph. X is 4, y is 1. There's another point. X is 5, y is 2. Okay, so I now have 3 points on the graph. If I draw vertical lines through these, passes the vertical line test. So we have a function here. And finally, when I go to ask you for the domain and range of something like this, domain deals with x, but because it's not a continuous line, we don't need to use that x as every real number. We only deal that with functions that are continuous lines. So, our domain, we just put all our x's in, 3, 4, and 5. 3, 4, 5. That's our domain. And our range deals with our y-axis. We just put all of our y's. Because there's only 2 of them, we only need to write 2 in. And normally we write them in order from least to greatest. So our range is going to be 1 and 2. That's it. Once again, wasn't a continuous line, so we don't use that y as every real number. We just write the number straight in. Domain is 3, 4, and 5. Range is 1 and 2. That's all there is to that function. So, Lewis just asked in our standard equation, underline it here, when we go to actually graph a parabola, normally we use our 1 over 1 up, 2 over 4 up. We only use that when a is 1. When a is 1, they actually don't usually put a number in for a. So normally when you're looking at it, it'll look something like this. And they'll have something that's f at x equals, and then they'll just go either straight to the x squared, or they'll go straight to the x in brackets. If there's nothing there, it's assumed a is 1. So when a is 1, that's when we go to the vertex of our parabola. We go over 1, up 1, both ways. So those are our 2 next points. Then we go over 2, up 4. 1, 2, 3, 4. Over 2, 1, 2, 4. So when a is 1, that's when we use our standard to draw the rest of the parabola. If a is greater than 1, then we have to multiply by it. Let's do an example of it, just so you guys have an idea. I'll come back up here just because I have space. So this isn't technically the definitions part, but we're kind of running out of space, so I'm going to do it up here. Normally we start at our vertex, we go 1 over 1 up, 2 over 4 up, 3 over 9 up, that's about there. This is our standard. So whenever a is equal to 1, I'll write that in here. Whenever a is equal to 1, we use our 1 over 1 up, 2 over 4 up, 3 over 9 up. We use that. If a is any number but 1, so let's say we have an a is 3, we have to start at the vertex still. We'd still move 1 over, 2 over, 3 over. We still only move over by 1 space at a time. But when we go up, instead of moving 1 up, we have to multiply by 3. So what that'll look like, we start here, we go 1 over, and 1 squared is 1, and we multiply by our a. Our a is 3, so we go up by 3. 1, 2, 3. Here's our next point. We go 1 over, 1, 2, 3 up. When we go over 2 spots, we take the number 2 squared, which is 4, and that's why we normally move up 4. We multiply it by a. That's going to be 4 times 3, 12. So when we're at 2, we go up 12. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12. So somewhere up there. Same idea here. And if you notice, our parabola, when we connect it, it's very stretched. A is greater than 1, hence we have a stretched parabola. Let's say if A was a half. A half's usually an easy one to work with. If A is a half, we still start at our normal vertex, but this time when we go over 1, we'll do the calculations on the side here. We take that 1 squared, but we times it by a half. 1 squared times a half is still just a half. So instead of going up a full unit, I know it's hard to see, I only go up a half unit. When I go over 2, 2 squared is 4 times a half, I go over 2. So I go up 2. So I go 1, 2 over, up 2, 1, 2. Here's my next point. 2 over, 1, 2. Let's do another one that's a little wider so you have an idea of this. Let's try 6. No, 6 too high. We'll do 4. Say we're going to move 4 spots over. We would take 4 and square it, then multiply it by a half. 4 squared is 16. 16 times a half is 8. So I go over 4. 1, 2, 3, 4. So I've moved over 4. I go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So my parabola is now wider than our original one. Same idea. If we went over 4, up 8, this parabola is wider than when A was 1, so it's considered compressed. I know that's really tight, hard to see in there. When I put it online, use Zoom. It'll be easier, okay? Let's view this whole thing right now. Ugh. That's not really nice to look at, eh? Okay. I can fix this. Give me a second. So, that's everything we've covered today. Well, that's a lot.